So I'm waiting for the students to be joined. Yeah. I'll wait for 2 minutes more, then I'll start the lecture. So hello students, how are you? I hope you are doing good. So we are here with the question discussion on work, energy and power. And this is our part 4 for question discussion. Okay. So in the last class, we have seen some numerical from work energy theorem. Now in this class also, we are going to see some numerical based on work energy theorem and the concept of potential energy that I want to introduce to yourself. Okay. So let's just started with this. So here are some questions that is important, and is the that is a kind of question that has the more probability to be asked in the examination. So in this question, if you will read, so a vehicle of mass m accelerate starting from rest while the engine supplied constant power p. So show that the velocity of the vehicle is given as a function of time by v is equals to 2 pt by m raised to the power 1 by 2, or you can say it is the square root of 2 pt by m. So in this question, there is a relation we have to develop, and that kind of question has a tendency to be asked when we relate the constant power to velocity, constant power to the let's say displacement. So these are the question that is important also and very conceptual. If you follow the rule of mathematics and follow the concept of physics, you will definitely get through this question. Okay. So in this question, the very first thing that is given to you, that particle is starting from rest, that the vehicle vehicle of mass m is accelerate but starting from the rest. Okay. Which means the initial velocity of the vehicle is zero. Now, while the power engine supplies constant power P, so that the velocity of the vehicle is given as a function of time by v is equals to square root of 2pt by m. Now, I must show you some concept regarding power. Okay? So here we are going to discuss power. Now, power is equals to, power is nothing but the rate of work done. Okay? It is the rate of work done, which means work done, work done per unit time divided by time. So power is represented by P, so you can get it like this, delta W by delta T. Okay. Although we have two types of power, so power K we have two types. First is the average power, and the second one is the instantaneous power. Instantaneous power. If you want to, if you are interested in getting the power at a particular instant, if you want to know the value of a power, value of the power at a particular instant, so you will go through this instantaneous power. And if you want to calculate the power for a time interval which is great enough, so that kind of power is the average power. So I must write it here that this average power is when delta T is sufficient enough, sufficient. So you can define this power average to be delta W by delta T. But when delta T tends to zero, so you can take the limit that P instantaneous is equals to limit delta T tends to zero, delta W by delta T, and it will finally becomes dW by dt. These are the infinitesimal time periods. This is a differential work and this is a differential time. Okay? Which is itself having a very low value. Got it? Now, so this is about the power. Now, one of the important formula also when you relate the power with work done and the velocity. Okay? So power we defined as that work done by time. You can say that this work done is nothing but force into displacement. Okay, got it? Or you must say, just for your better understanding, we will consider it to be dw by dt. Now, d by dt, w is nothing but f dot ts. Okay, sorry, f dot s. Now, you can say that f is the constant. If f is a constant force, so you can say that it is ds by dt. Okay. This ds by dt is nothing but the velocity. So here, this is the dot product, you must say. This is the dot product. So in between, there must be a dot product. So here you have f dot b. ठीक है. That is why the power is a scalar quantity. So it is a scalar quantity. ठीक है. Now, if you open this expression, so it will give you that FV cos of theta. Okay. So what you will say that if you take this cos theta with this F cos theta into V. So this F cos theta will become the tangential component of force. Okay. You always remember that in power, only the tangential component of force is responsible. Okay. Got it? If you will stay in this block, here is the force F is applied by an angle theta to this block. So what you will see, this is the F cos theta and this is F sin theta. Now, which one of the force is responsible for work done if the displacement is in this direction? Okay. So which force is responsible for the work done? So definitely F cos theta is responsible for the work done. Because the work done by F sin theta will be 0. Why? Because F sin theta and the displacement itself is at 90 degree. So cos 90 will become 0 when you open the dot product. So cos 90 will become 0. So the work done by this F sin theta will be 0. So that is why only the component of force which is in the direction of displacement has responsible for the work done. And work done per unit time is power. So that is why the component of force which is in the direction of the displacement, in simple, in the direction of velocity, because change in displacement is the velocity. Okay? So that is why you have to take that component of force which is in the direction of displacement or in the direction of velocity. Okay? And it's usually the tangential component of force. So this is it, what I have to tell you about the power. Now, move back to this question. Now, in this question, a vehicle of mass m is given, which is starting its motion, accelerating motion from rest, which means initially is it at rest? So the initial speed, initial speed is equals to 0. And the engine of the vehicle is supplying a constant power P. Let's say this power P, which is given by the formula that we have learned is F dot, because here V is been asked. So we are applying this formula. Okay. Now we have to establish the relation between velocity and power. So what you can say that this power P is equals to F V. Okay. Hello students, how are you? So is the screen is visible to you, JNV Ahmednagar, and I'm audible to you. So here is the very first question that we are doing. Okay. So we know the formula for power. Power is nothing but force multiplied by velocity. Although the another formula for power is work done per unit time. And this F dot V come from this, derived from this one. Okay. So here we have a power P which is constant and the velocity. Now we have to establish the relation between velocity and power as it given in the question. So what we are going to do, we are using this formula and try to establish a relation between power and velocity. So you can say that this power P is equals to, according to Newton's second law, F is equals to ma into V. Now P is equals to m. What is the value of A? You can write it as dV by dt. It is a change of velocity per unit time into. Now, what do you have? You have, you take m on the other side. So P by m into V dV by dt. Now take the dt in this side. So you will have V dV is equals to P by m dt. Now if you integrate this, you know the limits that at time t is equals to 0, the initial speed is 0 because the particle is starting from, the vehicle is starting from rest. And at time t, sorry, at time t, the velocity will become v, let's say. The integration of v dv is same as integration of x dx, which is equals to x square by 2 plus c. But here we will not take this c because it is a definite integration. So it will become v square by 2, limit are 0 to v, is equals to p by m into t. Now, for the limit, you will have v square by is equals to pt by m. Now take this 2 on the other side, the v square you will have as 2 pt by m. Now v is equals to square root of 2 pt by m, or you will say that 2 pt by m raised to the power 1 by 2. So this is the relation between what we have to develop. Okay. Hello JNV Bhavnagar, how are you? You guys are joining late today. What is the reason, yeah? Any kind of problem you are facing, or you are enjoying the Sunday? So one of the question that can be established from this question, that one can ask about the relation between displacement and the power. Okay. So you do not have to do anything now. You just have to take this relationship. What is V is equals to 2 pt by m raised to the power 1 by 2. You have to take that relation. Now you know that dv, v is nothing but ds by dt. So 2 pt by m raised to the power 1 by 2. Now you take ds is equals to 2 pt, 2p by m raised to the power 1 by 2 you will separate, and this is t raised to the power 1 by 2 into dt. Now if you integrate it, putting the same limit at t is equals to 0, the displacement must be 0 because it is starting from rest. And at time t, let the displacement be s. So it will become s is equals to, now 2p by m is a constant quantity. So we will take it out. So integration of 0 to t, t raised to the power 1 by 2 dt. Now what is the integration of square root of t? It will be minus 2 by root 2. Let's see. Integration of root x dx. You know that integration of x raised to the power n dx is equals to x raised to the power n plus 1 divided by n plus 1 plus c. So in this x raised to the power 1 by 2 dx, what is the value of n? It is 1 by 2. So you will put it here in this formula. So what do you have? X raised to the power 1 by 2 plus 1 divided by 1 by 2 plus 1 plus c. So what do you have? You have 3 by 2 in the denominator. So it will go up. It will become 2 by 3 into x raised to the power 3 by 2 plus c. Okay? So same we have here. We have here a variable st. So s is equals to, you can say, 2p by m raised to the power 1 by 2 and t raised to the power 1 by 2 dt. We have integration as 2 by 3 t raised to the power 3 by 2. ठीक है. So finally you can write this expression as s is equals to 2 by 3 2p by m raised to the power 1 by 2 into t raised to the power 3 by 2. This is the relation between displacement and power. ठीक है. So that is the one possibility that could be asked from this question. ठीक है ना. Now we move on to the next question. Yeah. So like I am talking about the relationship between V and S, between power and velocity, between power and displacement has been asked commonly. And you will see in 2018 the same question is being asked. So body of mass start moving from rest like the previous one along x-axis so that its initial velocity varies as v is equals to a root s, where a is a constant and s is the distance covered by the body. Now the total work done by all the forces acting on the body in the first second after starting of the motion is. So again we have to establish a relationship. So you need to focus on that kind of question in which a relationship has been asked. Okay? Because they are very simple yet conceptual questions. Okay? No. So here in this question, the relationship V is equals to A root S is given. Okay? So we have to find out the total work done by all the forces acting on the body in first second after we start the motion. Now for work done, what two things we need? We need force and the displacement. है ना? These two things we need. And for these two things, we are provided with this relationship. Now, we know that dv is nothing but ds by dt. And that is how we are getting the value of s here is equals to a root s. Okay? So what you can say, you can integrate this. This will become ds by root s. You have to take same variable to the same side equals to a dt. Here a is not the acceleration. It is a constant quantity. Okay. So if you integrate it now, so at time t is equals to 0 because the body is starting from rest. So the displacement or the distance traveled by it will be 0. And at time t, let the distance traveled by it be s. So you can take now here it is 1 by root s. Okay. So if you take it on the upper side, if you take it on the upside, so it will become integration of 0 to s raised to the power minus 1 by 2. ठीक है. ds is equals to 0 to t a dt. ठीक है. Now if you integrate it now, it will become s raised to the power minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1. Minus half plus 1 will become plus half. So it will give you s raised to the power 1 by 2 divided by 1 by 2. This will go in the numerator side. So it will give you 2 root s. Okay. So just keep remember these types of integration, direct integration. You have to remember that for 1 by root s, it will be 2 root s. Okay. So it will give you 2 root s. And integration limits are from 0 to s is equals to, it will a constant, it is a constant a, so you can take it out, so this will become 80. Now it will become 2 root s is equals to 80, and if you get a square of it, it will become 4s is equals to a square t square. So here a relationship between s and t, you will have s is equals to a square t square by 4. Now s part is clear to you. Okay, as we have find it out, now we have to find out the force. Simple, very simple, take step by step. So F is equals to mass into acceleration. Okay, now this A and this A are different. This A is a constant which is given to us, this A is the acceleration. So F is equals to m, acceleration you can write dv by dt. Can you calculate this dv by dt? Yes, of course. From this relation we can calculate it. Okay. So what we are going to do, we are using this relation v is equals to a root s. So what you are going to do, you are going to integrate, oh, sorry, you are going to square of it, so that this term will become simpler to you. V square is equals to a root s, a square s. Now if you differentiate it with respect to time, so v square का differentiation क्या होगा, 2v into dv by dt. Okay, and this a square is constant, so you can take it out. The differentiation of s will be ds by dt. Now this ds by dt will become v, so it will cancel one of the v. So what do you have? You have dv by dt is equals to a square by 2. Put this value in this equation number 2. Okay. So what do you have? We'll see in the next page. You will have force as mass into dv by dt, and we have calculated the value of dv by dt, which is a square by 2. This a is not the acceleration, I'm telling you again. It is a constant. So F is equals to m into dv by dt is a square by 2. Now both the quantity you know the F, you know the S. What is the value of S? S is a square t square by 4. Okay? So it is a square t square by 4. Now what is work done? Work done is F dot S. So put the values of it in it. M a square by 2 into a square t square by 4. So what do you have? You have m a raised to the power 4 t square by 8. So this is the work done. Now match the answer. So it is 1 by 8 a raised to the power 4 t square. So option A is the correct option. Okay? I hope you are clear with this. Got it? If you have any kind of doubt, you can write it in the chat box. Okay? Now, this question. You must try this question. A wedge of mass m, capital M is equals to 4m, lies on a frictionless plane. A particle of mass m approaches the wedge with speed v. Now, there is no friction between the particle and the plane, or between the particle and the wedge. So, the maximum height climbed by the particle on the wedge is given by. So, this question is very simple, and it is from the yeah, of course you have to use this concept of concept of conservation of mechanical energy and conservation of momentum. Okay, so try to solve this question. I'm giving you 1 minute to solve this question. Okay, try to solve this question. I have told you in the previous lesson, in the previous lecture, I have told you that where we can apply the law of conservation of energy. So we can apply the law of conservation of energy when there is only the conservative force are acting. Okay? ठीक है? And the concept of conservation of momentum you can only apply when there is no net force. So here in this question, a wedge is given to you and there is a particle block is also given to you and this is the surface. Okay. So this surface is also frictionless. This surface is also frictionless. Okay. Now what will happen when this block is approaching to this wedge? Let's say W, and this is mass M. So it is approaching with a speed V to this. When it hit this and start climbing on it, this wedge will also start moving because there is no friction to stop it. Okay. So at that time, the wedge will also start moving. Okay. So we have to calculate that what is the speed by which it is moving. Okay. And then we can apply the law of conservation of energy. Okay. So this is the concept. Key when this block try to reach this wedge and start climbing on it, this wedge will also start moving with certain velocity. Okay. So let's say for a particular instant, this the velocity of this wedge and this block is v. Okay. Okay. So here, if you apply, firstly, apply conservation of momentum. How we are able to apply the momentum conservation? Because there is no net force acting on this. Okay. If you consider it to be a system, this wedge and this block, if you consider it to be a system, this is to be considered to be a system. So whatever the forces are acting on it, like the normal force is only acting because there is no friction. So this normal force will become the internal force. Internal force. But in the conservation of momentum, we will only see, we are only interested in the, we are only interested in the external forces. So there must be a no external force. Okay. So there, if there is no external force, so you can conserve the momentum. So initially, if you talk about the momentum in this system will be only this small m particle is moving with a velocity v, and or we will write it as P initial of the system is equals to P final. Okay. So P initially the wedge you will see approaches the wedge. Okay. And the wedge is in rest. Okay. But only the particle, only this point mass m is moving. Okay. So you will have mass into velocity plus 0 for wedge. But finally what you will have, this system will move. Now, if the particle of mass m is moving with certain velocity in this direction, we are not interested in that. We are only interested in the horizontal velocity. So block of mass m will also move with the speed with which the wedge is moving. Okay? And the whole system will move with the speed of wedge. You can say that. So here you will have as like that capital M plus small m into V dash. ठीक? Now, mv is equals to, what is the value of capital M? It is 4M. So you can write it as 4M plus M is equals to 5M into V dash. So you can calculate the value of V dash from here. It is V upon 5. So this is the velocity of wedge here. Got it? No. Now the velocity of wedge you have got. And let's say the particle is at here. Okay? M. At a height h. Got it? So in this question, if you have noticed, you have been asked the maximum height claimed by the particle on the wedge. So when particle achieve this maximum height, which means उससे ज्यादा height achieve नहीं करेगा, इसका मतलब क्या है कि वो wedge पर वहां रुक जाएगा. The speed of that particular mass particle on the wedge will become zero. ठीक है? Got it? So this is the height h, and now the velocity of this particle will be zero. ठीक है? Got it? So if you apply the conservation of energy. Just give me 10 to 15 seconds. Just give me that. Yeah, JNV Bhavnagar, you have raised the hand. Any kind of doubt you are having, you can write it in the chat box. Okay. Now we have to apply the conservation of energy. Okay. What is the conservation of energy? Kinetic energy plus initial potential energy is equals to final kinetic energy plus final potential energy. And we are talking about the potential energy of this mass. Okay. So we are conserving the potential energy for small m mass particle. Initially, the particle is starting from this point, and suppose this is the reference level. Reference level. Okay. So initially, this block of mass m is moving with a speed of v. So initially, the kinetic energy will be mv square plus the potential energy becomes zero because it is on the reference line. So there is no height achieved by this particle at this instant. So the potential energy will become zero. Now finally, final kinetic energy will be 1 by 2 times, because these two This two system is moving with a speed v dash. So what we can say, it is m plus 4m moving with a speed of v dash square. So this is the energy, kinetic energy of the system now. Plus, what is the potential energy? The potential energy is mgh. Okay, of this mass. That is mgh. Now, 1 by 2 times mv square is equals to 1 by 2 times 5m. V dash means v square by 25, because v dash is nothing but v by 5. We have calculated it, equals to, sorry, plus mgh. Okay. Now, 5 5 is 25. So you can cancel out this m from both the side. So you will have v square by 2 equals to v square by 10 plus gh. And this h is the maximum height. Okay. And one thing that you won't notice, but I do, is that when it achieves the maximum height, the velocity of this particle will become zero. That is why in the final kinetic energy, only the speed of this wedge is came into contrast. And why the wedge? Because now this block of mass m is moving with the speed of wedge, because इसकी तो velocity zero हो गई ना, and it is lying on the wedge, and wedge is moving with certain velocity. So now it is moving with the wedge velocity. That is why I have taken this. Only the wedge is moving in this system. Okay. Now you can take this gh max is equals to v square by 2 minus v square by 10. So take the LCM as 10. This will become 5v square minus v square gh max. So gh max will become 5v square minus v square is 4v square divided by 10, and it will become 2v square by 5, or you can say that h max is nothing but 2v square by 5g. So this is the value of v square, h max. Okay, we have calculated the value of v dash by this, the conservation of momentum, and we have calculated the height by conservation of potential energy. Okay, so always remember, if the maximum height is being asked, so you have to apply the conservation. There is a possibility that you can apply the conservation of potential energy, but when the speed is asked, so two possibilities are there. Either you apply the work energy theorem, or you apply the conservation of momentum if the net force on the system is zero. Okay. So option C, I think, is the correct option, 2v square by 5g. Now, this is also, these are the latest question, like 2019-20 kind of question, na? So, and it is very simple question. If you see the previous one, it is very simple. Only two concepts you have to introduce. Now in this question, you will see. You can definitely attempt it. Okay. And I believe in you that you can do this question, na? Okay. So a force on a 2 kg object, so that its position is given as a function of time as x is equals to 3t square plus 5. Now what is the work done by the force in the first 5 seconds? So here you can say that x is equals to nothing but 3t square plus 5. Now सबसे पहले देखो कि क्या पूछा गया, तो वर्क डन इज बीन आस्क्ड. वर्क डन क्या होता है? फोर्स इनटू डिस्प्लेसमेंट. डिस्प्लेसमेंट के बारे में हमें दिया हुआ है, x इज इक्वल टू 3t स्क्वायर प्लस 5. द रिलेशन इज बीन गिवन. 5 सेकंड में पूछ रहा है, तो 5 सेकंड तक हम डिस्प्लेसमेंट भी निकाल सकते हैं. पुट द वैल्यू ऑफ t इज इक्वल टू 5. नाउ द ओनली थिंग दैट इज मिसिंग इज force into force. And what is force? Force is mass into acceleration. Mass is also given. Only the acceleration is missing. And acceleration is nothing but dv by dt. What is v? V is again ds by dt. So you can tell that it is d2s by dt square. And here the s is given in terms of x. So you will say that is d2x by dt square. So what you have to do? You have to just differentiate this this expression two times. Put the value of and find the value of force, and then put t is equals to 5 to calculate the displacement at 5 and calculate the work. It's very simple. So differentiate this, you will have dx by dt is equals to 6t plus 0 because the differentiation of 5 is 0. Now dx, if you again differentiate it, it will give you d2x by dt square, which is nothing but the acceleration, which is 6. So acceleration is constant here. If the acceleration is constant, which means the force is also constant. Okay. So you can calculate the force is equals to mass into acceleration. What is mass? Mass is 2 kg, acceleration is 6. So you have provided with 12 Newton, the force is acting. Okay. Suppose if this expression, this final expression of acceleration is also variable, is also dependent on it, then you have to calculate the value of f at t is equals to 5 because it is a variable quantity. Okay. But here the acceleration is fixed, so the force will also fixed. Now force you will have. Now the only thing you need is the displacement, 3t square plus 5. The expression is this. Okay. At t is equals to 0, the displacement is 5, which means initially the body is not on 0. Initially it is at x is equals to 5. And at t is equals to 5, if you put the value here, so it will give you 3 into 25 plus 5. This is the x as 5. This is x as 0. So 25, it is a 75 plus 5 is 80. Okay. Let's say this is in meter. This is also meter. So it has displaced from 5 to x is equals to 80. So what is the displacement? Displacement is 80 minus 5 is 75. Now most of you guys, what will you think that at x is t is equals to 5, the expression is 80. You will not interested in calculating it 0, and you put the 80 and then calculate the work done, and it will be a wrong answer. Okay. Now the work done here is force, which is 12, and displacement, which is 75. So if you calculate it, 75 into 12 is equals to 2 5 ja 10, 2 7 ja 14, 15, 1 5 ja 5, 7. So it is 0, 0, 9. So it will give you 900 joule of work. Okay. Got it? Got it? So it's a very simple question. Okay. Now move on to the next question. Before this question, I want to introduce you this question. Look, a particle of mass 0.2 kg is moving in one dimension under a force that delivers a constant power 0.5 watt to a particle. If the initial speed is 0, then what is the speed after 5 seconds? So if I want to solve this question, it's a very simple question. Power is given to you as 0.5 watt. Mass is given to you as 0.2 kg. Okay? If the initial speed is 0, which means u initial is given as 0, then we have to find the speed as 5 seconds. वी नो दैट पावर का फॉर्मूला आई हैव टोल्ड यू, पावर इज इक्वल टू फोर्स मल्टीप्लाई बाय द वेलोसिटी। ठीक है। नाउ P इज इक्वल टू फोर्स को हम लिख सकते हैं मास इंटू एक्सेलरेशन इंटू वी। ठीक है। नाउ P इज इक्वल टू एक्सेलरेशन को भी हम लिख सकते हैं dv बाई dt। ठीक है। So you can take this dt here and dv here, so it will give you m mv dv is equals to p dt. You can take this m this side, so v dv will become p by m into dt. If you integrate it, the limits are given to you. You have to calculate the speed at 5 seconds. So at t is equals to 0, the speed is 0 because the initial speed is 0. At t is equals to 5, you have to calculate the speed which is v. v dv का integration v square by 2, limits are 0 to p by m is the constant quantity, so integration of dt will give you t, and limit are 5 to 0, so it will become 5. Now put the limit, so you will have v square by 2. You have the value of power which is zero point 0.5. You have the value of mass which is zero point 0.2 into 5. Now this point will cancel. So you will have, and this 2 will also cancel out. So you have v square is equals to 25. So v you will have as 5 meter per second. Look how simple this question is. Okay. How simple this question is. And this question is being asked in JEE Advance. Okay. Now just a second.